because that isn't the goal of the program. The goal is to get good at making judgment calls, and not going to get that except in the way you're describing, like asking for potential edge cases to consider. That kind of dialogue, pair programming partner that I think the best of these AI tools represent. That's amazing, but that's very different to plug in the question, gen the answer.
Welcome to Software Unscripted. I'm your host, Richard Feldman. Today I'm talking with Will Sentance, the teacher of the Hard Parts series and the founder and CEO of CodeSmith, which is a software engineering and AI immersive education program. We talk about how AI is intersecting with modern programming education, what's considered fundamentals these days, and how Will thinks about teaching object-oriented and functional programming. I want to give a massive thank you to everyone who's been supporting Software Unscripted on Patreon. If you enjoy these episodes and you'd like to become a supporter too, check out patreon.com/softwareunscripted. And now, AI in programming education. All right, Will, thanks for joining me.
Lovely to be here.
So you run a programming education program, and one of the things I've been wondering about is there's all these new developments in AI and Copilot and ChatGPT and large language models helping programmers out. How do you see that sort of affecting the way that you teach programming to beginners?
Absolutely fascinating question that I think speaks to a whole range of topics. One being, what is really the point of education? For me, it has two major parts. One is to get some conceptual model of something into the head of somebody else. That might be how Elm works, how functional programming works. That might be, how a particular protocol works. But then the other half of it is to establish in people what I would call kind of capacities. They're things like the ability to work out for themselves in future how any new programming language works, work out for themselves in the future how, the new, latest, maybe most regarded programming languages like rock.
This is going great. This is a perfect episode so far.
Exactly. What a pitch. For those, who aren't super fans, that is a actually very cool, lightweight functional programming language that Richard themselves made. And so, but for real, like that is as important as the knowledge thing you're putting into the head of somebody else is the instilling through some degree of a whole bunch of things, your investment in them, your conviction to them that it's worth them spending the time, hitting blocks in understanding, let's say Elm, functional programming as a concept is challenging. It's not as intuitive as more, explicit, I'm going to get these phrases wrong, but, procedural, more traditional programming approaches. It is conceptually challenging, and therefore you're going to hit a lot of blocks in understanding. Half of the point of education is to give people the conviction and your investment in them that they will then overcome those blocks and keep going, building up kind of a self-perpetuating conviction that future blocks they'll be able to overcome. So once you start thinking about education like that, you can see how the rise of new tools can be kind of put within that framework. So one thing I'll kind of clarify is CodeSmith free material has always taken people to a place where, in theory, and this is a bit of a stretch, but it is ultimately somewhat true, they could go and get a entry-level job just from the free learning materials. That's the kind of theory. Being that in a sense, you can get a lot of that stuff from so many places. And the point of CodeSmith is to get you from there, maybe 4 out of 10 on the way to a autonomous engineer able to work on anything you choose, through to where you're able to actually get that kind of, we call it mid-level job. And that's always put CodeSmith in a bit of a different position. And I think in a sense, for me, gives me a different perspective on the role of, let's say, large language models, but specifically Copilot and ChatGPT being the most kind of typically used. I think there's so much to say. I think for CodeSmith in practical terms, there's always been the answer somewhat online. To some extent, you could always probably go and copy and paste and figure out the right Stack Overflow answer. You could even post your question on Stack Overflow and get the answer, put it in. It doesn't quite work. Post again, put it in. Doesn't quite work. Okay, now we're there. And that was never the point of CodeSmith, and it was never the point of becoming an engineer. The point of becoming an engineer was such that you could own that figuring out yourself. And to get to that point, you can't really shortcut by just, quote, making it work. You have to build through, as I say, hitting blocks. And then what we do is through pair programming in CodeSmith and before the program as well, verbalizing through how the code is working, describing what it's doing, start to build your own mental model. That's kind of a full conception of all the pieces of how code runs, which no amount of sort of chat GPT can give you. Well, actually, that's not fair. It can. It is a brilliant communicator of how code runs. The question is, are you going to stick at working hand in hand with ChatGPT? And just like self-teaching in general, the answer might be yes. But for most of us, me very much included, and I went to a coding school, I needed somebody who says, you are going to sit here and spend 10 hours a day hitting blocks, feeling frustrated, and keeping going and talking through how it's working, building your mental model without stopping. And that's really what you're doing when you go to CodeSmith. You could do it by yourself with the help of ChatGPT and the ability to talk it back and forwards. You could definitely do it by yourself. What you're really paying for is people saying, I'm going to be there alongside you so that you don't stop after 10 minutes and go, shoot, I'll go and get a cup of tea, or
Yeah.
you don't stop after, hitting the block and say, I'll try learning something else now. But instead you keep pushing through. And ChatGPT can help you do that. It's the best technical communicator. I love conversing with it. But you still, only half of the job is that. Half of the job is someone saying, yeah, but keep going, keep watching over. And also, understanding the right things, the right questions to even ask. So in terms of CodeSmith, we've also added 3 full more new units, which we can talk about on using and integrating, I guess, prediction. My concept is that the full stack engineer now, the stack is not only front end, back end, infrastructure, tooling, it's also prediction, productized prediction, predicting user behavior, but also pixels and text. And that's a whole part of the curriculum. But particularly in terms of how do people learn, it is a fascinating question. And what do, GPTs or chat bots, whatever, do for that? It's a fascinating question, but one that I think is best understood through what is the point of education. And only a bit of it is the knowledge. A lot of it is the capacities, and I don't know how to instill those in people besides another person putting their energy into you to help grow, yourself through, because capacity is something that's only forged through probably a little bit of struggle. And most of us understandably need help to do that. So in that sense, not much changes, but in terms of, but because of understanding what education really is about. Does that give some sense?
That makes a lot of sense. I mean, there's a few different ways that I use large language models to help myself program things. One is just to understand a piece of code and just be like, hey, what is this doing? Or what are the implications of this? Or just ideation. What are some edge cases I might want to think about in this? Just having someone, suggest those things to me. But another thing that I very commonly use it for is I'm like, okay, I have this idea of this code that I want to exist. I could write all that out by hand, but it'll be faster if I say, you generate this for me, and then I will review it and make changes to it.
Yep.
But that reviewing it and making changes to it part is really critical. And it feels like I've had to, in order to get the actual time savings out of that, I've had to sharpen my skill set of being a really careful reviewer, because the mistakes that it makes are usually different than the mistakes a human makes, in my experience. Like the types of mistakes that a human will make is often like they overlook an edge case or something like that, whereas large language models can do that too, but also they sometimes will generate code that it's not so much that there's an overlooked edge case as that it's almost like it misunderstood what I was saying in a way that a human wouldn't, and fundamentally wrote a test that doesn't actually test what I wanted it to test, or doesn't actually test anything useful at all. And being able to catch those things and recognize oh, this actually is not useful code to me, or this code needs to be changed in a particular way. if I hadn't had all the experience of programming without any access to an LLM, I don't know how I would have gotten those skills. And to your point about like, I don't know how else to teach that. That resonates with me because I also don't know
Yeah.
how else I could have learned the reviewing skills if the entire time I'd been programming, I'd been doing it with, an AI other than like just learning it the hard way where it's like I'm like, oh, it gave me some code and I don't know how to evaluate whether this code is actually doing what I want or not, so ship it, and then it just breaks
Yeah.
horribly in
Yeah. Yeah. Yeah.
production. And you do that enough times and you're like, maybe I need to get better at reviewing this.
Which, by the way, I think is honestly not dissimilar to how a lot of people end up, discovering these things because thinking about what goes into products, production environments. Is that in a CS degree? I mean, as you say, the concept of breaking out a problem in full and reflecting on it is, but I don't know if um, the idea of really thoughtful code review is in a computer science degree. I think that
Yeah.
you may get that in an internship during your computer science degree, but like, no, I think that's absolutely right. I mean, it's a bit of a counterfactual that's hard to evaluate, right? Because, and actually, I think one of the advantages I always had with writing my talks, my kind of hard part stuff, was because I'm not, I don't know if I want to say I'm not a very good engineer, I barely say I am at all. You know, it's like, in a way, it was a huge advantage because some of that stuff that I was teaching, especially in the early hard parts workshops, I was learning as I go that for many
Mm.
people who are ever standing in front of a room explaining stuff, I'm afraid a map function is not something that they're like, huh? It's reached a level of intuition for them where joining up the pieces of how it works is kind of, they can't put themselves in that headspace. Whereas when I was making my hard parts workshops, um, I did not know how a map function worked, which is not a great testament to my engineering ability. But that meant that I truly built explaining it from the ground up. And I think that's, analogous here a little bit is it's quite hard to assess, as you say, the counterfactual. What if I had not, developed the under the hood understanding that came before, or, the piecing it together understanding that came before the GPT support, the LLM support. Could I still have done what I'm doing? I think the answer is probably no. It's probably no different to before, and I'd be curious how it's going to evolve. Like, uh, I mean, I did a little fireside chat with an alum called Brandy, and she was in talent at Delta before CodeSmith, and then she went to Microsoft afterwards, and then she's now just gone to Google. She was Microsoft as a software engineer, and now at Google as a technical program manager, but still half the time, coding. And the way she used the cliched phrase of, it's a cliche, it's a joke, but it's actually entirely true. 10% of your time is spent writing code, 90% fixing it. And it's like, that
Mm.
sounds like, oh, it's like, I don't know. To me, it's like, that sounds, absolutely right of the day to day because, I was watching my friend who works in a Dropbox kind of, I want to say, AI exploratory team. I shouldn't know if I should say this. We were watching the France game in the pub, and they were working on they were working at the same time. It was like 1 p.m. on a Monday, and they were working at the same time. And I was watching over their shoulder what they were doing, and like so much is wrestling through dealing with other people, and not in a like they're not being helpful, but just literally relevant other people in getting a product across the line, including other engineers, um, explaining to them why your approach to handling the particular edge case is probably preferable and why theirs, might work, but have you thought about this limitation of it? I mean, it's probably not the sit in the corner, crank out code at the exceptional rate that makes you feel like being a software engineer might avoid needing to work with people. It's probably not that role, but the role that includes a lot of, hey, negotiation with the other engineers, explaining how that approach might be better thought of this way. That I mean, that stuff's all the stuff you're describing, the
Yeah.
reviewing code, the making judgment calls, the ability to reason through problems, the ability to get your concept of it into the head of somebody else. Um, what we have to watch out for at CodeSmith is just teaching. In the end, it is a knowledge driving program that's also trying to build your capacities. Is to instill in people the idea that the answer is not the goal. The making it work is not
Yeah.
the only goal. Meaning, yes, technically you could probably submit it into ChatGPT and get the answer, but that really is not useful when you're building the foundations. It's just not
Yeah.
helpful because you're doing something different. The person who's doing that on the job isn't trying to just get the answer, because on the job there ain't just an answer. There's a whole range of
Right.
different calls you're going to make, like, oh, we could do it that way but this way. So when you're in the program, you might think you're just trying to get to an answer. Engineering's never been about that. But if you did just plug it in, get the code that technically makes it work, you would misunderstand what engineering really is. So it's important for us to instill that in them so that they don't just quote try and get the answer, because that isn't the goal of the program. The goal is to
Yeah.
get good at making judgment calls, and you're not going to get that except in the way you're describing, like asking for potential edge cases to consider. That kind of dialogue, pair programming partner that I think the best of these AI tools represent. That's amazing, but that's very different to plug in the question, gen the answer.
Right. Yeah, for sure. I mean, speaking of pair programming, like you mentioned that that's a big part of what you do at CodeSmith for like learning purposes. I'm a
Mm-hmm.
big fan of pair programming, and I've done it in various different jobs. And one of the things that is interesting to me is in past jobs, it's always felt like there's a bit of a productivity cost there. And I know some people will say like, "Oh no, there isn't." Like your net like coming out ahead, and like maybe sometimes like depending on what the project is. But I've always thought of it as like, well, we're not going to ship as much code as we would if we were each independently working. However, that's made up for or compensated for depending on what the project is by we're having the discussions in real time, and having those discussions asynchronously would be more expensive, or we come up with a better design because we're able to rapid fire go back and forth while looking at the code in context, or there's knowledge sharing happening, and that knowledge would have been otherwise me crashing into the walls and like beating my head against the wall and like
Yeah,
taking a
yeah.
lot longer to acquire that knowledge the hard way than if we were pair
Or
programming.
any insights that you did make, you'd have to you know they're probably not going to be passed on, or if they are,
Yeah.
it's you got to make sure someone reads it. you know
Right. Yeah.
Instead they're there right with you.
And so I'm working at this company Zed now, and Zed makes a code editor, and one of the banner features, which I didn't until I used it, I didn't really understand why it was a banner feature, is this like collaborative thing, and it basically is like it just feels like Google Docs, where like you and I are in the same like workspace working on the same project, but there's two cursors and one of them is remote, so it feels like kind of like pair programming with two keyboards, but it's more than that. One of my coworkers mentioned that she was doing it with somebody who was like a much more experienced engineer who had not used anything like this. And he said it was like, this doesn't feel like pair programming. It feels like parallel programming, because as soon as we
Mm.
get to the like discussion part where the discussion's over and we get to the actual like let's implement stuff, you can have like in the same file, or in some cases even the same line, I've done that before, where like one person's editing one chunk and one person's editing another chunk. And like something that came up early on was I was chatting with one of my coworkers in like pair programming, and I was like, oh, let's make this change. I just spotted an opportunity to refactor. You do the top one, I'll do the bottom one, and we just did it right there at the same time.
Yeah,
And
wow.
that felt like really cool, but also I've always wondered about like what does that type of experience mean for people who are learning, because I've used it now as a professional and I'm like, this is great, I love it, like we use it every single time I pair program at work. But similar to AI, it feels like the type of tool that has the ability to sort of give you a big productivity boost, but it is sort of like it requires that you actually do pair programming in order to like actually get any benefit out of that. Because if you're used to just being a lone wolf who just kind of sits down and like cranks on it, and then like maybe you ask a question
Yeah,
in Slack or something, it's just kind of a different process. And I'm kind of curious how you think about pair programming in the context of learning. Like, is that
yeah.
something that like students would benefit from, or like would is the way that you do it kind of like different, or how do you think about those things?
No, it's such an interesting question. It's one that when we first went remote, we wrestled with so much. Um, how do you uh, achieve, particularly the in-person dynamic? By the way, other pieces like the one of the things we wanted to try and achieve was the old in-person experience of someone looking over your shoulder and say, "Oh, how are you
Yeah.
doing that?" Um, yeah, it was a fascinating experience that really, I mean, we did it actually before COVID because we had a part-time remote, part-time program, remote, like I think about it, I want to say like 8 months before COVID happened. Um, but yeah, we designed it intentionally to try and emulate that in-person experience. I think so. Pair programming at CodeSmith works with, I think, a slight look. I think pair programming at CodeSmith and in general in education, because I know at least one other program that does it. Um, it it is emulating the professional approach, but I think it is also trying to achieve slightly different goals. The things you shared there about shared learnings, about the ability to um, build the collective understanding of the code base, capture edge cases earlier. Honestly, there is a lot of analogy, but within CodeSmith and within a learning environment, what you're really trying to do is fight the wrong type of behaviors that limit your growth. So when you're learning to code, a phrase I never loved, because I think it is an endless thing. And I think learning, that's kind of the wrong mentality for it. There is this tendency to fall into one of two behavioral patterns or types. One is I am the person who needs to, anytime I come across a mysterious reference, word, keyword, concept, I'm going to go and study, meaning you never get your hands dirty in the code.
Oh
And
yeah.
then the other type is the person who wants to build something and they're going to understand nothing and they're going to plug and play and just make it work. And those two behaviors are both legitimate. Neither of them's wrong. The problem is, as you become experienced, you become really good at balancing those two. You know when you need to go and figure things out, and you probably built a lot of the solid foundations, but honestly, half the time you haven't. You've got to go and figure stuff out for the next topic, the next domain, but you also know when to make it work, experiment, test, put your understanding that you might or might not fully have into practice and just like see if you can push it through. Those two instincts, some people are instinctively really one, some are really the other. Some people, sometimes we're probably one of either of those. The point of the pair programming at CodeSmith in part is to prevent anyone being locked in either of those behaviors. When I first pair programmed at the coding school I went to 10 years ago, 10 years ago, I still remember we sat down with the very first challenges with this person. I think his name was John, but yeah, he said, I said, let's go and sort of read up a bit. I spent like 5-10 minutes reading, and I was ready to study up for the rest of the kind of sessions, learning how it worked, whatever. And he goes, "Hey, do you mind if we get started? Or I get started and you can join." I'm like, I was still studying. So you can probably tell I was very, very much. And if you look at the hard parts content, to be honest, it's basically the result of someone studying very hard, which is not, a bit ironic. But he said to me, "Hey, do you mind get started?" And I was like, and I had to go in and get my hands dirty. And the way we actually lay it out in practice is one person's a navigator, one person's a driver. The navigator has to explain in response to any prompt or feature goal how they would approach it with clarity sufficient that the person who's implementing their hands on the keyboard is able to do so. The person who's explaining cannot ever say, "Hey, let me show you what I mean." That's going to require a level of ability to talk through how the code's working, what the goal is, get precise with describing. And I just did a workshop on Tuesday, a sort of free public workshop about the tech market in 2024. And I said to people afterwards, feel free to connect on LinkedIn. I can take a look at your LinkedIn, or give any pointers on your own job search to people just in the broader community, not at CodeSmith. And a bunch of people reached out and they're like, hey, I'm in the technical bits and that's where I seem to lose it. And I'm like, the thing that you most need in those technical interviews, it isn't that there's always a right answer. It's definitely, obviously, ideal if you have some closer to right answer in the interview, but it's how are you talking through what's happening? That is what you
Right.
want as a hirer. You want confidence. Like, I just give an example. I just messaged someone on not an engineer, but someone who's, well, actually they are, sorry, but they're helping out with some implementation stuff for I won't be too precise, but they're a contractor helping out. I want to be, but contractor who's just joined us to help out with something. And I was like, all I want is, can you walk me through how you're implementing this thing? I want a little screenshot. I want the judgment calls, the explanation of why and how you've done it. Like, that is what you want, because that gives you the ability to help. Obviously, you have to trust, but also gives you the ability to help make the judgment calls at a high level, but also to trust because you understand that they understand, that they're able to explain it.
Yeah.
So that's the driver-navigator relationship, the explaining between, but it also, within an education setting, forces the hands of both partners. Nobody can become hey, do you mind to just go off and study? Because I guess you could spend a few minutes studying, understanding a concept before you come back together, but not long. You're doing it with somebody else.
Yeah.
But also that nobody's just like the make it worker who goes, copy and paste. Oh, try again. Move that line down a line. Try again, because they're not allowed to. Their hands cannot touch the keyboard. They're only allowed to describe what they want to happen, and it instills in you the right behaviors. The look at each line and debug, by saying what am I expecting in this line? And so we have a help desk, right, where TAs, we call them fellows, can come over and help and answer, but it's really a mini training session in that process. It's not, here's the answer. And of course, that can be vastly frustrating for people. It's like, bloody hell, I'm sitting here 10 hours and just give me the bloody answer so I can move on. But it's like, no, we're here as fellows, TAs, to give you a mini training session in the right behaviors, which would be, this is not working. Well, what did you expect to happen in this function? Okay,
Yeah.
great. Well, what's actually happened? Okay, so what's the argument that's been passed? What are you expecting it to be in order that the output would be what you're claiming you think it will be? Okay. Well, is it therefore that argument's not been passed to that function? Okay, so where's that function being called? Okay, let's have a look. And back you go. So that training approach is the point of help desk, but it's also the point of pair programming, because you can't just move it all around. You've got to say, hey, let's try this because I suspect this is what's going wrong. So with an education setting, and to be fair, even engineers doing it in production for years are still, repeating in a good way those patterns of behavior and continuing to practice them. But within an education setting, it's primarily to instill the right behaviors when instinctively any of us would not choose to do those, because it's very reasonable to say, I don't understand this, let me go study for 4 hours. And then you did no code, and or make it work and not go and study at all, and therefore have no idea what's happening. So it's that forcing of the right patterns of behavior. That's how we use it. Within the remote setting, I think one thing to say is, if no one's touching the keyboard at the same time, there's something to be said that the live partnering is not as vital. I don't know if I fully agree with that, because I still think, why wouldn't, and I think we, as you describe, that back and forth is invaluable, especially in projects. And so in practice, what you're describing as the feature to be able to, Google Docs your code, I think has been and is a vital part of the program. You've got to have that sense of, I can see the person is looking over my shoulder as a pair programming partner because their cursor is right there in the code base with me. So yeah, in practice, it's pretty important.
Yeah, that makes a lot of sense. I definitely think about you going back to, you mentioned earlier, sort of predicting, and I think about these two concepts of do I want to study the problem or do I want to dive in and start implementing? and sort of the balance between those two being a really important skill to develop. I definitely think that those two intersect with predicting in some interesting ways. If you're building a feature where you don't actually know like how you want to implement it, or even necessarily how you want it to work, what you want the user experience to be. I've definitely experienced this more at startups than at like bigger companies that have like a really big process for, like, we have project managers, and the project managers work with the UX designers, and then they come out with, here are some tickets, and you take a ticket off the heap, and then you're going to go implement the thing according to the spec. In that kind of world, it seems like it's not as important maybe to keep all these things in mind. Maybe only a subset of them are as important. But like the stuff I'm doing at Zed right now, I mean, this just happened pretty recently. Like, I'm working on sort of a greenfield feature where it's like, we have some idea for how we want to improve this thing, but there's just so many different possible ways we could improve it. Here's an idea for how we might improve it. But as I'm developing it, I'm trying to think at the same time, number one, how can I ship something really fast that lets me try it out and iterate on it? And part of it is intentionally hacked together because I don't want to gold plate it. That's the term we use, gold plating it, is it's like, I don't want to gold plate it yet because we don't even know if this is the direction we want to go yet. We might end up throwing this whole thing out. And so however much time we spent getting to that point of validation where we know the answer to the question, do we want to keep going in this direction, or do we want to scrap it and, you know, turn around and try something else? The amount of time we spent to get there is really important to, you know, how long the feature ends up taking as a whole. But at the same time, I also don't want to just say like, all right, well, let's just try this and we're just going to gung-ho like jam on this. I also want to be thinking ahead about, okay, let me think down, where is the end of this road? Like, if I build this feature in this way, is it going to cause performance problems unavoidably? Like, is there some way I can anticipate being able to solve these problems? Is it going
How do you
to
go about that process? Like, yeah, how do you? Is it pure experience? Do you get on a whiteboard?
I think
Yeah,
I think a lot of it is experience, but in particular, I would say that a lot of it comes down to a combination of just like having done the wrong thing a lot of times in the past, and just thinking
yeah.
back to like, oh wait, there was a bad thing that happened. But also, I mean, kind of studying, just like learning about like different, like I mean, I mentioned performance, like learning about performance optimization techniques and stuff like that, and knowing like, oh wait a minute, like here are some things I need to keep in mind for this, or as the case may be, or like, for example, am I going to be able to parallelize this if the performance is bad? Like, how can I parallelize this? Like, how much CPU do I have available in the context of all the other things the application is doing? If you're doing like web development, maybe in the browser, maybe that doesn't come up as often, or like those particular considerations compared to doing
But
you know,
equivalent
code editor.
questions, right?
Yeah,
Yeah,
right. And
yeah,
like,
equivalent.
or thinking about like in a web app context, it's usually the performance stuff is very often about database things. It's like, okay, well, am I going to be able to like index the right things such that this query can be fast, you know? Or like, how many different third party data sources do I need to bring in? Which of those requests can I parallelize, or which ones have to be sequential, and how much, you know, does that result in the user having to wait unavoidably?
Hmm.
When you're hacking together a mockup, you might just be like, okay, let's just like, I'll just assume I got the data and like, don't worry about it. But then I want to be thinking ahead to like, well, hang on, am I going to actually be able to create this experience for real? Or am I going to like have a really nice, cool demo? And then, you know, like 2 months down the line after I've been gold plating it, I'm like, oh, actually using the real thing is not the same experience as the demo.
Yeah, and look, I've got so many thoughts on what you're saying there. One, by the way, the often performance. We talk a lot about CodeSmith. The performance greatest bottleneck is so often, the engineer's ability to reason about the complexity, and or, by the
Totally.
way, the performance, the price of. So we've moved. Our long-term engineering leaders just moved on after many years, and it's been a wonderful part of the team. But we've had somebody over the last 3 weeks interviewing them to build out a, you know, basically spec of the entire
Ah,
system, and it's great. It's great. He's done a really good job, honestly. I was like, it was a bit. He didn't talk too much in the process to me about what. I'm very happy with the. I'm really happy. It's really good, but like. the, some of the, they're judgment calls to make, but when you have a relatively small application, but with a lot of instances, these are judgment calls that can work, can create challenges later on.
Right.
And, you know, that is the nature of this work, is that permanent. And it's one of the things that I think is perhaps the most appealing part of, and, you get it in any workplace and any role, but particularly in software engineering, in a non-artificial way, not just because, oh, there's always new things to learn because people are creating new things, but there are genuinely new insights to take on. There's growth, as you say, to have. There's stuff to learn that makes you better at your day-to-day job, maybe for the rest of your career, and that's really satisfying for people. And it's one of the best things about the role. And I personally look at software engineering as very much kind of a broad, central to organizations, not a million miles away from being an analyst or anything else. You're a big part of making a product happen. And that involves a lot of the generic, vital workplace skills and capacities like problem solving, like technical communication, like, non-technical communication. All these things are like very universal. But there are also, and that makes it, therefore a career that opens a lot of doors. You can be a software engineer, and then I've seen someone who's become a policy advisor in the White
Huh.
House, and she was a software engineer at Pinterest before, and at Amazon before that, ML engineer at Amazon before that. So it's a door opening, generalist, wonderful for it, career path. But there are some special things about it that you're not going to get in probably your investment analyst role in the same way. Like, your knowledge continues to become, or growing your knowledge does make you better at your job over the years. And I'm
Sure.
not saying that as an investment banker or whatever the other role might be, or as a, I don't know, product manager or whatever, it's not that knowledge isn't important there. But I don't know. There's something really cool about the fact that within software engineering, and that's why you see there's so much learning material. You ain't finding a ton of like IB or whatever content for people who want to become super. There ain't a Hacker News for that. Because it does increasingly become a little bit closer to the who the familiarity, the ability to vibe in a investment lunch, whatever.
Yeah.
And that's of course part of being a good software engineer. Those are good human skills, but shoot, you also genuinely will grow your, as you describe, you'll be better at forecasting whether that product feature is going to be sustainable based on things you learned at a conference that you went to and engaged with a great talk 6 months ago. And that is really cool. That's like a nice thing to have that little bit of academic growth within a professional environment. I think it's obviously very appreciated, but I talk a lot about software engineering being this kind of core thing in modern teams that's very like, I don't know, like a great career, but it's also a really intellectually satisfying thing for people as well. So yeah, it's cool.
I agree. Yeah. I mean, I have a whole podcast about how interesting these things are.
Yeah, right.
Yeah. So another question that I'm curious about is, so I've always wondered about this concept of what people call teaching the fundamentals. And the thing that I wonder is, what do people think of as the fundamentals? Because I remember back 20 years ago when I was doing a computer science undergraduate degree, I took a course on operating systems, and one of the things that we were supposed to do is to sort of build from scratch some of the operating system primitives, like some of the things that the operating system does. And on the one hand, that's a cool experience. But on the other hand,
Yeah.
like if then later on in my career, I was doing a lot of JavaScript in the browser, and you just don't get anywhere near the operating system. Like there's no
Mm,
way that like accessing those primitives, it's like the layers are, you have the operating system followed by the browser, followed by the browser's JavaScript interpreter, followed by the JIT on top of that interpreter. And then that's what your actual code is interfacing with. And that's sort of determining how fast it runs and like
yep.
how it's behaving and when garbage collection pauses happen and things like that. And so knowing about like, oh, okay, here's how I can do a virtual allocation. It's like, yeah, I'm so far removed from that. But then on the other hand, you can say a lot of people are working in terms of not just JavaScript, but the layers on top of JavaScript. Like JavaScript is the lowest layer. Then on top of that, you have React. And on top of React, you have, some state management system. And on top of that, you have some GraphQL thing. And so in that world, it can be that JavaScript is what fundamentals means because that's the lowest layer that you're able to
Mm.
interact with in the browser. And so I wonder about, and then of course, some people mean by fundamentals like big O notation and asymptotic complexity.
Mm,
And then I think a valid criticism of that is if you're really concerned about performance, you might want to think more about like memory caches. And if you're doing JavaScript, like about what is the JIT actually doing? Um,
mm.
and there's a lot of different ways you can go with that question of like, what are the fundamentals? Even if fundamentally you think, we want to teach the fundamentals. It's like, well, what do you mean by fundamentals? And I'm just kind of curious what your take is on that. Like, when you think about, obviously, I'm assuming some percentage of the CodeSmith curriculum is like, let me teach you like the tools that people are using right now, so you have familiarity with them right when you graduate. But
Yep,
then
yep.
also some percentage of it is the fundamentals, whatever that means. Like, what does that mean to you?
So, I mean, so much good stuff in the question, but I think about it a lot. So, the way I try and explain it would be uh, giving people the ability to build a mental model. When you think about how an operating system works, when you think about the notion of a kernel, the kernel, you're thinking in your head, probably visually, maybe not, but like you're holding in your head the component pieces, probably how they are structured. Maybe there's some inputs into it, which might be uh, data and or steps, procedures, and then there's some output, some sort of consequence of those procedures, and then there's a
Yeah,
system in which those procedures are happening. That is a complex system, by the way, no different to a people one, like the job search. I often think there's a lot of analogy between, no different to an economic system, like users making or uh, economic actors, people making choices, and an economy being the output, or a price of a good being an output, or a trade being an output. They're all complex systems where, if you can, you want to be able to try and figure out that complex system and hold it in your head for one that you haven't yet seen, which might be, for example, as you say, a highly abstracted code base that's using, or it might be, a whole bunch of infrastructural pieces, like, multiple machines. It might be, a whole bunch of React components. All of them
sure.
are a complex, like, system. And what the point of CodeSmith curriculum design, and I think what a good computer science degree is really trying to do for you, but by the way, it's analogous to a good economics degree and maybe a good, and other engineering degrees, is in theory to show you, and this is where the fundamentals bit kind of comes in, show you, uh, ideally, and this is the point of the hard parts workshops, before CodeSmith and on the Front End Masters platform, to give you a complete mental model with everything you need for that abstraction layer and nothing you don't for, in the case of the hard parts of JavaScript stuff, the JavaScript runtime. As you say, that's as low as it goes. But it could easily be, as it might be in a CS degree, for an operating system and all its constituent parts. What you're doing is you're seeing, yes, you're building the mental model of something that's important for when it's more abstracted, perhaps to understand, but you're also getting exposed to what even is the notion of a complete conceptual mental model of something. What that does for you is a whole bunch of like revelations. For me, one of the biggest ones is nothing in the programming language is like truth. They're all features designed to try and make the person using that system's life a bit easier. So
Hmm.
when you have, I don't know, uh, really anything, lexical scoping, the idea that there would be state data available at a function calls moment that is namespaced to that function because it was defined alongside that function definition. And that therefore, when you execute that function at any later moment, you have that namespace data available to you. You can run with it without having to reference it by a dot notation or some other way, but also it not being, unnecessarily available all over your runtime, all over your application's runtime. That sort of idea, if you can fully map out, is a revelation. It's like, oh, shoot, now I have this mental model of how code's executing. I can also start to realize that any system is somewhat designed to try and make your life easier. So the hard part stuff is what you start with at CodeSmith, is like total and utter guardrails, handrails. You have total map of how code runs within the JavaScript language, uh, built out for you. If you sit and watch those talks, you will end watched them probably a few times with a complete understanding of how code runs. However, there ain't no hard parts for the code base you pick up when you join your, role.
Right.
Um, there's no complete mental model. You're going to need to build it. So the design of the CodeSmith program is to steadily remove those guardrails. Start with, going to the program, and now you're doing challenges within, higher level React, Node, whatever. You do now have a full mental model of the stuff that goes into that, JavaScript, but also you've witnessed a complete mental model, what it even looks like. Whether it was JavaScript, they could have done it on, computer science and operating system. Doesn't per se matter. It's definitely helpful that it's the stuff that's the input of React and Node, JavaScript, but then you're doing it within React and Node, and now you're doing coding challenges which are just open-ended enough to allow you not to kind of plug and play the answer, but structured enough to kind of keep you moving through building stuff. Then you move into projects that are more your conventional, personal projects. But now it's a little bit more, you've got to build the model of how that particular app you're building is working in your head. Then they do this open source contribution stuff where they're going to build a tool likely for how to, visualize Elm's state. I don't know. Yeah, tracking in Elm, maybe it's got lots of built-in tools. But now to do that, you're going to potentially need to build a mental model. Like when you're building a full stack app, a lot of people have had that mental model before. It's pretty established. But now you're building a dev tool that's managing and viewing state within an application. Maybe no one's fully mapped out that before. And that prepares you for when you get on the job, where you're hopefully now you've seen in hard parts what a complete understanding of a system, think in economics, what they call a general equilibrium model, which is, I guess, a model, a simplification of how an economic system works, buyers and sellers, and how it ends up with a price and, in an economy as a whole. You've seen it. By the end of the program, you're hopefully able to build your own for the given, once you join the job, code base that you're entering. And to me, therefore, fundamentals is really, ideally, probably, you built a mental model of the core system in which a lot of the judgment calls are being made, which is the programming runtime, let's say JavaScript, but also its secondary goal is that you've seen a set of fundamentals and how they join together, because every system has its set of fundamental constituent parts. It might be the operating system components, but it might be in your code base the bunch of, weird customizations they've done in side files on how React is implemented in their code base.
Sure.
And that's okay too. And what you want is that people can come out of the program able to now build their own hard parts for the code base and or any system they're joining, the bloody workplace, and start to piece together the inputs, what's really causing the space in which that stuff's happening, and then the outputs, because that's really what a model is. It's the inputs, the system, and the outputs. And that would be, in that oddball React configuration, what are the constituent decisions that perhaps that have been made? What are the pieces? And sure, under the hood of that might be JavaScript features as well. And so having a mental model of JavaScript, great. But if you didn't, you've at least, and that's why you can move into another language or into another area, you've at least learned and seen what a complete mental model even is. Because we're not born with that. Wasn't born with it. I got lucky to have particularly a professor at Oxford who I do these papers for in economics or other things, and they would say to me, I was really proud of my laundry list of, here's why these things happened in political system or whatever here. And they said to me, you need to build a complete model. What are the constituent elements, the micro foundations they call it? What are the bits going in? In programming runtime, it might be the idea that there is data. There are instructions that can alter and modify that data. There is the notion of stuff running one after another, a thread of execution. There is a place in which code can run and have some little data attached to it, an execution context. What are those constituent pieces? What are the lines that are actually executing? And then what are the consequences of that system that play out? And you can see them. And I mean, that's really, people think hard parts is about diagramming or whatever. Really, it's primarily about trying to build a model of that system and introduce the pieces one by one so that somebody can look at any new complex system and go, what's really happening here? And yeah, that's to me what fundamentals is really about. Uh,
Yeah, that's a great, very detailed answer. Thank you.
a bit of me says that uh, I almost wish the world had started from a functional programming paradigm for thinking about language use, um, because while it can feel incredibly unintuitive, that's I think partly primarily because we forget how incredibly unintuitive the style of writing code uh, that I'd been trying to learn for sort of 8, 10 years before I ended up doing it. And I'm sure the same, for you, actually in itself is a funny old model. And easily the world could have started people at, 12, 13, 14 or whatever, what someone wants to try and quote, learn to code with a functional paradigm as a starting point. And they'd have ended up finding it ultimately far more intuitive in the long term. So I just think it's awesome that you've created a sort of a lighter weight starting point with the language you're building. So I just wanted to say that's very cool.
Well, thank you. I appreciate it. I actually, if you have time, I have a follow up question to that that
Yeah,
I'm curious
please.
to get your thoughts on. So, one of the things that I've thought about is if you think about how the machine works, it's very imperative. Like the way the CPU instructions work, it's like even an addition is mutating something at the CPU level.
Mm,
It's changing a register. Um, so everything's very imperative. And it makes sense to me that you would start from this is what the machine does and then build programming languages on top of that would be imperative and mutate a lot of things. That all makes a lot of
mm-hmm.
sense to me. What's a little bit strange to me is that if you start with imperative, it makes sense to me also how procedural programming would evolve from that naturally because you have these like go-tos and jumps to get everywhere and it's making a big mess. You say, let's organize things into procedures. I get why that makes sense. Okay. But then you have this interesting split, and it's a little bit not accurate in terms of the history, but let's just pretend that what happened was there was one group of people who said, let's do object-oriented programming. Let's add that on top
Mm,
of our existing procedural thing. And there's another group that said, let's do functional. And the functional group was mostly in academia and really interested in math. And the object-oriented group was, well, they also were interested in math. But at any rate, the point was that the object-oriented sort of paradigm ended up taking over the world and being like every language, like especially ever since the 1990s, there's this great Joe Armstrong quote who created Erlang. And he said, saying that your language was not object oriented was like swearing in church. Like, why would you confess to, something like that your language was not object oriented? But today that seems to be not the case anymore. It seems like a lot of new languages are, if
right.
they're talking, like maybe they are object oriented, but in a lot of cases it feels like maybe that's for backwards compatibility reasons because they're built on top of an existing language that was object oriented, or like in Go's case, it's just not object oriented.
Mm-hmm.
Rust is not object oriented. Those are the most recent like two languages to get popular, I would
Mm-hmm.
say. And then even like
Mm-hmm.
other languages like Swift and Kotlin are like advertising, hey, we have good functional features. They're kind of like
Mm.
advertising that that's like, the new thing, even though it's quite an old thing. And I wonder about, as an educator, how do you think about like, setting aside whether it's imperative versus functional, declarative, whatever else, about object orientation in the classroom, about like, you mentioned, we have this kind of funny way of doing things. I'm curious what parts of the funny way of, doing programming that is most widely done today is like, has to do with teaching like classes and inheritance. And then there's a lot of like the good parts stuff where you say like, well, here's how this works, but probably don't actually do it this way. Like don't use inheritance that much, if you could avoid it, things like that. I'm kind of curious how you think about those things.
Yeah, wow. So we do teach both approaches, slash, even that is a bit of a narrow way of defining it, as you say, reducing to one approach or another is probably missing the point a bit. Um, but equally, you don't just want a kind of, again, laundry list of different features without a coherent strategy behind it. Um, I think one thing one does is really help people understand that these things aren't truths. Like inheritance isn't like this is in the ether out there that was discovered. They are efforts by programming language designers to help engineers building stuff that is potentially vastly complex with tens, hundreds of thousands of lines of code to reason about complex interdependencies of data and language, instructions that can change that data, use it, display it, modify it, pass it elsewhere, use it elsewhere, and that if you're doing that, you are going to make some effort to set up restrictions to what you're able to do so that it becomes a bit more predictable, it becomes a bit more structured, but at your very core, there are some needs you have. Needs like, I want to have the pertinent data for this functionality. Let's say it's a game and you've got some scores of the user or some information about the user. I want to have that pertinent data probably relatively associated in my code base with the instructions that are going to be able to change that data, use that data in some way. But I'm going to need to have trade-offs there because actually I might want to use that somewhere else. Okay, so now I need to have some idea of private or public, and also I want to somehow maybe have some place in which I'm defining those relationships because I'm going to have a lot of instances of those relationships in practice. But these are all serving an underlying goal of the developer's ability to reason about, at its very core, data and functionality and how they are associated, where there's a heck of a lot of data and a heck of a lot of functionality and an interdependence between them across potentially a vast code base of hundreds of thousands of lines. And hey, wonderful that you could be able to affect that data from anywhere in the application, but that's an interdependency tree, so to speak, of relationships between data and code that can change that data, that is maybe, trillions of permutations, to be exaggerating. But, in theory, right, handshake across any line can affect any bit of data, any line of code in any part of the application. And sure, you can modularize and all these sorts of things, but the need is there. And therefore, any of these approaches are efforts to solve those underlying needs. And that to me comes back to that point you made about fundamentals. Includes, if I were to give the fundamentals, I would say includes the principle of developers, software engineers have a limited brain capacity. We do. And therefore, a lot of the stuff you get introduced to is basically trying to make the most of that capacity and not lead us to be, oh, shoot, I've changed that bit up there with this this function call that's changed that bit of state that I lost track of and someone else has done it too. And therefore, it is designed like this. And so that to me is perhaps in terms of teaching, not in terms of learning all the features respectively of the different approaches, but in terms of teaching, what you're trying to do is point out that each of these different features is trying to serve the kind of goals that you as an engineer are going to have for the rest of your life, which is often very base goals, like humans can't keep track of all that much state in their brains. We're not built for that.
Right.
And therefore, what can you do to try and manage that? And each of these approaches is trying to do that. That's where potentially I think a computer science degree, where it's not taught with that in mind, can speak to it as truths. Now, I think if you do a programming languages design course, I think it's one of the coolest courses you can do in a CS degree, I think there's a lot of emphasis on these as features designed to make a developer better able to reason. But even then, it can also be a lot about performance. And in reality, it always comes back to, at this point, performance is important. Developer reasoning is a lot of the time your biggest bottleneck. And so I think thinking about these things from that lens in terms of teaching is how we tend to do it. Does that make sense?
Yeah, absolutely. Nice. Will, thanks so much for joining me. I really appreciate your taking the time to answer all my questions about these things. I learned a lot about modern education of programming, so really appreciate it.
I really, really appreciate it. I loved the conversation. As I say, shout out to all the teaching and mentorship you've done at CodeSmith as well. It's meant a lot, and congrats on the wonderful 2-year-old as well.
Thanks so much. That's it for this one. I hope you liked it. You can find links to some of the things we talked about in the show notes, and if you've been enjoying these episodes, consider supporting the show on Patreon at patreon.com/softwareunscripted. Until next time.